we're starting to get into proofs, which is why we've been dealing with logic this whole time to begin with, is so we can start thinking logically and learning how to do proofs in geometry. In this section, there's a whole bunch of properties of equality and properties of congruence. They're really, we already know it. Now we just have words that go with it as to what it is. I mean, when we solve an algebraic equation, we use these properties to solve it. But we've never really had to write them down as the reason that something is happening. So as an example, the reflexive property of equality, A is equal to itself. It seems very intuitive, but you're actually going to use this property in a proof. Okay, so that's the reflexive property. The symmetric property, it's almost like the commutative property. The order doesn't matter. If A equals B, B equals A. Okay? The transitive property is a lot like the law of syllogism. If A equals B and B equals C, then A equals C. That's the transitive property. The substitution property, if A equals B, then I can substitute B in its place. That's just substitution. The addition property, if I add something to the one side of an equation, I have to add it to the other. We already do this when we solve algebraic equations, right? Subtraction, the same thing. If I subtract something from one side, I have to subtract it from the other.
Is this on Canvas?
Yep. This is the textbook that you were supposed to have read before you got here. Yeah.
Yes, I definitely read this.
I can tell.
Too.
I'm sure. And the multiplication and division property is the same thing. You multiply both sides, one side by one number, you've got to multiply the other. You divide one side by a number, you've got to divide it by the other. And then the distributive property, if you've got a number on the outside of parentheses, you distribute it into both terms. Okay? Same exact properties of congruence. I could get there. Except, what's the difference between equality and a congruence? What does congruence mean again? They're the same size and shape. Okay, so if I said segment AB, or that AB was equal to itself, then I put a segment line over it. I've got to use the congruence instead of the equal sign, because now we're talking about the measure.
So they're equal to each other.
Yeah, it basically means that they're equal to each other. And so we have the same properties of congruence: reflexive, symmetric, transitive, as we did with equality. Okay. So I'm going to do this example on the board here. 2 times 3x minus 4 plus 11. If you were in algebra and you were asked to solve this, there are certain steps that we would go through. In geometry, we're going to use this process to show you how a 2-column proof looks. Okay, and I'm going to show you a 2-column proof to do this problem. And all of it's going to seem really intuitive, meaning you're going to say, yeah, that's exactly how you do it. Why do we have to write it out? Well, that's the way a proof is. You put a statement on the left, and you put a reason on the right. And we're going to use the properties that we just went over to do this. So what's the first step here?
Redistribute the 2 back in.
Okay, so I would say 6x minus 8 plus 11, come on board, equals x minus 27. Okay, and that would be my statement. The reason is the distributive property of equality. Okay, normally in algebra I don't have to tell you why. In geometry, we have to have this other statement on the other side. I know, like I said, you guys are going to say, well, that's just what you do. But now you've got to tell me why you're allowed to do that. What do I do next?
Add like terms.
Why? Add like terms.
We just have to explain everything.
Yep.
Oh my god.
That's going to be my favorite thing ever.
Okay, now what?
You can either subtract the 6x or add the 27.
Which one do you want to do?
Let's
27.
subtract this x. Minus 3.
Okay? So what allowed me to do that? The subtraction property of equality. And I'm going to say property of equality.
Yes, Cole, that's why she can say.
So,
Now what do? I'm going to subtract 3.
Divide by 5.
Same reason, right?
Let's do that.
This is division. Property of equality. Okay, now I get x equals negative 60. Okay, so that's how I would show, like do a 2-column proof for a simple algebraic equation.
Okay, I have a question.
Yeah.
How's it negative 60?
That's what I was going to
Or I don't know, 6.
I was,
Sorry.
I saw Caleb, he's like,
Yeah, so all of you look at me like that. Okay, I've done something wrong. Okay, so that's an example of a 2-column, a loose 2-column proof using an algebraic equation. Okay, so how does it look when we do it for geometry? So I'm going to go ahead and do example 3 here, which says if the measure of angle A plus the measure of angle B is 100, and the measure of angle B is 40, prove that angle A is an acute angle. I'm going to say that again, because maybe you can't read it. If the measure of angle A plus the measure of angle B equals 100 degrees, and the measure of angle B is 40 degrees, prove that the measure of angle A, or the A, is an acute angle. Well, we can do this in our head, right? If I asked you if angle A is an acute angle, you could tell me yes or no with this information without writing anything down.
Yes.
If I know A plus B is 100, and I know B is 40, I know A is 60, and 60 degrees is an acute angle. Done. It's not so easy when we're doing proofs, because we have to write each step and explain why. Okay? So if you can see this, or you could follow along with me on the textbook, the first thing in a 2-column proof that you always do is you restate the given. Restate the given. Have to. Okay? And so we put the measure of angle A plus the measure of angle B equals 100, and the measure of B is 40. We're restating what they told us. And the reason that you put in the right is the given. You just write the word given. With me? You always have to restate it. Because what happens is you get into more, I mean, there are mathematicians that are beyond my level that are doing proofs, and the proofs are not 3 lines. They're crazy proofs, okay? Yeah, I mean, I've seen someone actually prove that 0 times 1 is not 0 using there are crazy proofs that are out there. And the proof itself has to be standalone. Okay, so you're not going to see all the writing here. The proof has to be standalone. That's why we rewrite that first statement. So you have to write the first statement again, and you write given. Okay, the second statement was the measure of angle A plus 40 degrees is 100. Why were we able to do that? I know you can see the answer here, but if I'm given the angle B is 40, I can now substitute 40 for angle B in the first statement using the substitution property of equality. Okay, so they put substitution property of equality as their reason. Okay, so now they subtracted 40 from both sides in this step, right? Why? Subtraction property of equality. Now they get angle A is an acute angle. Well, the measure of angle A is 60. Now they say angle A is an acute angle, and why? The definition of an acute angle. Definition of acute angle tells you it's got to be less than 90. Okay, so something that is simple as this that we normally might do in our head, you're going to have to start learning how to make it into a proof. Some of the proofs that we'll get to when we get to similar triangles, that chapter, aren't going to be as intuitive to just do in your head. So being able to order your logical statements and write them down and put your reasons is going to be a really important skill. And that's why we're taking it slow in this chapter. We're making you write out how to solve an algebraic equation, how to do something simple like this proof. And I think in big ideas, a lot of the proofs that you're given, I think I gave you some, you'll end up getting like statements, and then you just have to order them. So you're not having to write these out on your own. You're going to actually get the reasons, and then you've got to match the reasons up with the statements that are in the proof, if that makes sense. Okay, so we're just kind of dipping our toes into proofs today. We'll definitely be doing more of them as we get into later chapters. Questions on this? You want me to go through the textbook check? Let's find it here. This is section 2.4. If A equals B and B equals C, then A equals C is an example of the transitive property of equality. That was in that table that I showed you at the beginning. If CD is congruent to AB, then AB is congruent to CD is an example of which property? Symmetric. So I think of symmetric as looking in a mirror.
That's what I did.
Or no, I think of reflexive, sorry. I think of reflexive as looking in a mirror.
I did one of them, and I just like kind of like picture it.
Yeah, symmetric is like the commutative property. You can switch the order, and it doesn't matter. If you give an angle CAB is congruent to angle BAC, what reason would you give for the following statement? The measure of angle CAB is congruent to the measure of angle BAC. That's the definition of congruent angles. If you're told the two angles are congruent, you know the measures are equal. Question 4. According to the video, when creating a two-column proof, the information you've been given must be stated in the proof itself. True. That's always the first row. And then question 5. Statements in a two-column proof that have the same reasons must be combined into one step. You don't have to. You can write it out two separate steps. You can combine it in one step if it's the same reason, but you don't have to. So it's not must. All right. That's it for this section. So go ahead and get to work.